Welcome back. This is Mr. Reeves again, and this is our third video on polynomials. The first one was just an introduction to what polynomials are. The second one was about adding and subtracting polynomials. And now we're going to get into multiplying polynomials. So again, before we actually start multiplying polynomials, I'd like to review a couple things with you. One is the distributive property. So hopefully the distributive property is something that you are very familiar with. Can't imagine you getting this far without being familiar with it. The distributive property says if you have A times the quantity of B plus C, that you can distribute that A and you get AB plus AC. So A times the quantity of B plus C equals AB plus AC. And of course we could do minus as well. So it's actually plus or minus. It's officially the distributive property of multiplication over addition and subtraction. So just a couple examples. Actually, a quick side note, a lot of students aren't really familiar with the power of the distributive property. So just real quick, if we were to do this using order of operations, according to order of operations, what would we do first here? Well, P stands for doing what's inside the parentheses. So we would do 7 plus 4, which is 11, and we would get 5 times, 11, and 5 times 11 is 55. So we don't need the distributive property when all we have are constants. But if instead I have 5, actually, let me do it again now with the distributive property, just to show you that I get the same result. The distributive property would say instead of adding 7 plus 4 first, do 5 times 7, and then do 5 times 4, and then add them together. So this is just an example to show that for this particular case, the distributive property gives you two values that are equal. And of course, it will always give you two values are equal. So if you can get the same result by using order of operations, why do we even need the distributive property? Well, here's why. Whoa, what just happened? Let's get that back. All right, here's why. Because if instead of 5 times 7 plus 4, I had 5 times x plus y, according to order of operations, I should be adding x and y together. But I don't know what x and y are, so I can't combine them. So I would be stuck. I couldn't simplify this. I couldn't do anything with it. But with the distributive property, I can multiply through and get 5x plus 5y. And you might say, well, why is that any better than what you had? Because now I have two terms that are separate and free. And if there were other x terms, I could combine them with this, or other y terms, I could combine them with this. Whereas when it looked like this, there was nothing I can do. So the power of the distributive property is it allows us to simplify expressions when we don't have the ability to combine the things inside the parentheses. Plus, sometimes it actually can make doing math overall a little bit easier. All right, so once again, that's just a quick reminder of the distributive property. Okay, I'd also like to remind you of something that supposedly you learned how to do back in elementary school, and that is multiplication using boxes. All right, so if I wanted to do 35 times 12, say. The traditional way of multiplying 35 times 12 would be to do 2 times 35. So here we go. We go 2 times 5 is 10, carry the 1. 2 times 3 is 6, plus 1 is 7. Then I'd put a 0 down and go 1 times 5 is 5, and 1 times 3 is 3. And I would get 0, and then I'd go 7 plus 5 is 12, carry the 1, and I get the answer of 420. And that algorithm has been used for years and years, and there's nothing wrong with it. But Recently, they've been teaching students a different way to prepare them for what we're about to do. So if I wanted to do 35 times 12, I could do 30 as 30 plus 5 and 12 as 10 plus 2. And then I can multiply each of these boxes because that 3 isn't really 3, it's 3 tens, which is 30. And that 1 is not really a 1, it's 10, it's 110. So this is first part is 30 times 10. And when you do 30 times 10, you get 300. And then 5 times 10 would be 50. And 30 times 2 would be 60. And 5 times 2 would be 10. And then if I wanted to know what 35 times 12 was, then I would add all these together. And I would have 300 plus 60 plus 50 plus 10. Well, that's going to give me 360 plus 60, which is 420. And I know what some of you are thinking, well, it's a heck of a lot easier to do it that way than to do it that way. And I understand that. But this way, there's all kinds of math you're doing that doesn't make any sense at all. When you're adding 7 to 5 here, you're not really adding 7 to 5. You're adding 7 tens to 5 tens, and you're getting 12 tens, but we put a 2 here and we carry the 1. Whereas this way, everything makes sense. All right? So this gets to the conceptual understanding, this gets to the answer quickly. All right, so I just wanted to give you that background because that background will help you understand multiplying polynomials. All right, so just a reminder, if we have one term like 5x squared, that is a monomial. If we had 5x squared plus 2x, that would be a binomial. And if we had 5x squared plus 3x plus 7, then that is a trinomial. And we could keep going, 4 terms, 5 terms, 6 terms. You can have as many terms in a polynomial as you want to. So when you are multiplying polynomials, you do it a little differently with monomials than you do with the other ones. But if you set it up this way, using rectangle multiplication, it makes it pretty straightforward to do it. So let's start off first with a monomial times a monomial. All right, so I'm going to put m times m for monomial times monomial. So I'm going to use that same one, 5x squared times, and let's do negative 4x to the third. I guess there's one more thing I should have revisited before we got to this, and that is the product rule for powers. So the product rule. So if I have a to the b times a to the c, do you remember what the answer is going to be? It's going to be a to the, is it b times c? No, it's what? B plus c, right? So if I have x to the third times x to the fifth, the answer is not x to the 15th. It's x to the what? That's right, x to the 8th power, because it's 3 plus 5, because this one is x times x times x, right? There's 3 of them there. And this is x times x times x times x times x. There's the 5 of them there. And so how many do you end up with? You don't end up with 15, you end up with 8 of them, right? Okay, sorry, should have hit that back earlier. All right, so just a reminder, right here we have coefficients. 5 is the coefficient and negative 4 is the coefficient. And I always tell my students, just pretend for a minute that you didn't have these there. If I gave you the problem 5 times negative 4, what answer would you give me? You would tell me 5 times negative 4, positive times a negative is a negative, and 5 times 4 is 20. And you get negative 20. And then what are we going to do here? We have 2x's and 3x's being multiplied. We're not going to do 2 times 3, 2 plus 3, and we get x to the fifth. So monomial times monomial multiplication, You've actually already done that. That was something we did in 8th grade, but we didn't call it multiplying monomials. We called it multiplying powers. But a monomial, remember, a polynomial is just made up of powers being added or subtracted. So monomial multiplication, what do? We multiply the coefficients and we add the exponents. We multiply the coefficients and we add the exponents. All right, so what about now if we do a monomial times a binomial? All right, so now I'm going to take that 5x squared and I'm going to multiply it by negative 3x to the x squared. And you know what? I'm just going to do negative 3x minus 7. How about that? All right. Okay. Anyone know where I'm going with this? Anyone see anything up above we went over? Oh, you guys are so smart. That's right. We're going to apply the what? The distributive property, right? We have this right here is our A, and this right here is our B, and this right here is our C. So I'm going to take that term on the outside and I'm going to multiply it by each of these terms here. So what am I going to get? I'm going to get 5x squared times negative 3x, right? Now, right here we have a subtraction, and this causes some confusion for some. Not as much in this case because this would be a positive times a positive being subtracted, but when you have negatives with subtractions, it gets really confusing. So my recommendation is before you multiply, when you're multiplying with polynomials here, I should make that eraser a little bit smaller, is change that subtraction to adding a negative. And that way we'll have a plus here. Whoops, back to blue. We'll have a plus here. And then what will we have? We will have 5x squared times negative 7. Students get caught up all the time with subtractions and negatives. So if you can change in polynomial operations and adding, subtracting, multiplying, and dividing, if you can learn to change subtraction to adding a negative, I'm telling you, your life will be a lot easier. You'll make a lot less mistakes. All right, so here we go. So let's multiply these two. 5 times negative 3 is negative 15. X squared times x is x to the third plus 5 times negative 7 is negative 35, and this doesn't have any x term here to get multiplied, so it's just negative 35x squared. Now again, I mentioned this in the previous video, even though I just encourage you to change subtraction to adding a negative, when you're done, you change it back. It is considered more simplified. We don't like having a plus next to a negative sign. In fact, we usually put parentheses when we do that. So adding a negative is the same as subtracting a positive. And we can't do anything more because these are not like terms. And we talked about that in the previous video, what like terms are. All right, so monomial times a monomial, multiply the coefficients, keep the base the same and add the exponent. A monomial times a binomial, we're going to go ahead and apply the distributive property. By the way, if we did a monomial times a trinomial, it would be the same thing, right? In fact, why don't we do that? A monomial times a trinomial. I'm going to make it a negative this time, just to show you what I was talking about. All right, I'm going to go ahead and move down one more line. So here we go. So I'm going to go negative 4x squared. Now let's make it, what the heck, we'll make it to the third power, times 5x squared minus 2x minus 8. All right, so again, since we're multiplying by a monomial, we're going to go ahead and apply the distributive property. All right, so this turns out to be right here, negative 4x cubed times 5x squared. All right, and then I'm going to follow my own advice here. I've got a subtraction. I'm going to change that to adding a negative. I've got a subtraction. I'm going to change that to adding a negative. And here we go. So now I have plus, right? Because now I'm doing this right here. Negative 4x cubed times negative 2x. So I'm multiplying that times that plus, again, now this is a plus because I made it a plus here, plus the negative 4x cubed times negative 8 because now this is a negative 8. So as you can see, this right here, outside the parentheses, I have distributed it to everything in here. That one's there. Can't use that color again. That one's there. And used yellow. How about pink? That one is there, right? The distributive property. Now we've got what? Monomial, 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 monomial. And here we go. Multiply the coefficients. Negative 4 times 5, negative 20. X to the, what are we going to do with these again? That's right. We're going to add them. Good. Plus negative 4 times negative 2. That's going to be a positive 8. What are we going to do with these? We're going to add them now. That's not a 0, remember. It's a what? It's a 1, right? So x to the 4th plus negative 4 times negative 8 is positive 32. X to the 3rd. We don't have an x term over here, so this one just kind of tags along. And again, these are not like terms. That's an x to the 5th, that's an x to the 4th, that's an x to the 3rd, so they can't be combined. I've got additions here, nothing to change. How nice is that? And that would be our answer. All right? So, and again, it really doesn't matter any polynomial when you're multiplying, when the first one you're multiplying by is a monomial, then you will always be using the distributive property up here, right? We're going to be using the distributive property when we are multiplying by monomials. Got it? Okay, what about if we're not multiplying by a monomial? What if we want to do a binomial times a binomial, or a binomial times a trinomial, or a trinomial times a 4-term polynomial? Well, that's where these rectangles here, this rectangle method is going to really come in handy. Now, I'd be lying to you if I told you you couldn't actually apply the distributive property with these other ones. You don't actually have to use the rectangle, but I'm telling you, the rectangle way is the way to go. All right, so let's go ahead and clear this out. Hopefully we don't need it again. Actually, can we just make a new sheet and then maybe we can get back to it? Oh, Mr. Reeves, you're so smart. All right, so here we go. All right, so let's do a binomial times a binomial, right? Or I guess the way we were writing it before, B times B. Okay, binomial is 2 terms. Binomial is 2 terms. I'm multiplying a 2-term times a 2-term, and 2 times 2 is 4. Like I said, Mr. Reeves, you're so smart. All right, so I'm going to go ahead and I'm going to make a rectangle. Don't make fun of my rectangle here, okay? And I'm going to divide that rectangle in half that way and in half that way approximately. This is just a sketch, all right? Okay, so many times when I've taught this to 8th graders, they go, oh, that's like a Punnett square in science, and that's absolutely what it is like. So I'm going to do, let's see here, x plus 7 times 3x minus 4. X plus 7 times 3x minus 4. So up here, I'm going to put x plus 7, and right here, I'm going to put 3x minus 4. So the first term in this one is x, the first term in this one is 3x. So I've got the first terms there, then I've got the second terms there, and we're going to fill in each of these boxes using multiplication in the same way we filled in each of these boxes using multiplication. Only this is a little easier because we don't have to worry about place values and where do we put zeros or things like that. All right, so what do we have first? We have this 3x times x. That's a monomial times a monomial. So what do we get here when we multiply those two together? We get 3x squared. And right here we have 3x times 7. What do we get when we multiply those two together? We get 21x. And then right here we have a negative 4 times an x, and we get a negative 4x. And finally we have a 7 times a negative 4, and we get a negative 28. So 2 terms times 2 terms gives you 4 terms. All right, now when we did this one over here, we could add all 4 of those together because they were all like terms. They were all constants. But when you look here, 3x squared, are any other ones of these x squareds? Nope. No other like terms for that one. This one right here, negative 28, that's a constant. Are these constants? Nope. No other constants. But these two are like terms. So this is what we're going to get. We're going to get 3x squared. And again, I'm going to follow my own advice here. I'm going to put plus 21x. Then I'm going to put, instead of minus 4x, I'm going to put plus negative 4x, because I always change subtracting a positive to adding a negative when I'm doing polynomial operations. And then I'm going to put plus negative 28. So again, you do not have to do this. This is just my recommendation when you're doing polynomial simplification, that you always make these addition. All right, but these two here are what? That's right, they are like terms. And so what do I get? I get 3x squared, 21 plus negative 4. What do I have more of? I have more positives. How many more do I have? 21 minus 4 is 17x. And then I get plus a negative 28. But remember, adding a negative, we switch it back when we're done to subtracting. I know some of you are thinking that was really silly, Mr. Reeves. You made it plus a minus just to change it back to minus a plus. I get it. I do. All right. So x plus 7 times 3x minus 4 is equal to 3x squared plus 17x minus 28. So in this case, a binomial times a binomial gave us a trinomial. And that usually will be the case, but later on you'll learn a couple special cases, which we call, actually a special case, which we call a difference of squares, where a binomial times a binomial turns out to be a binomial. There is another special case to which I was thinking of, which is squaring a binomial, but that also gives you a trinomial. All right, so let's do one more. How about if we do a binomial times a trinomial, or a b times a t? All right, so I'm going to go ahead and make my binomial, how about negative 4x minus 5? And my trinomial, I'm going to make negative 7x squared plus 2x minus 10. All right. So again, there is a way to do this by applying the distributive property twice, and you are welcome to learn that way. There's some great online videos that will teach you how to do it. But my favorite way is this rectangle way. Now, when we had a binomial times a binomial, it was 2 by 2, and we ended up with 4 squares. Well, now we have a binomial times a trinomial. It's going to be 2 times 3. So that's right, we're not looking for 4, we're looking for what? 6, right? So I'm going to make a longer rectangle this time. And this time it won't be a square like the other one was. Alrighty, here we go. All right, so it's 2 by 3. So over here is going to go my binomial. So I'm going to go negative 4x minus 5. Let me try that again. Negative 4x minus 5. And then up here, I'm going to have negative 7x squared plus 2x minus 10. All right, are you ready? Here we go. We are going to first multiply negative 4x times negative 7x squared plus 2x minus 10, which, by the way, is simply distributing this over this, right? It's actually just this rectangle method. It's just showing the distributive property in terms of a rectangle. All right, here we go. Negative 7 times negative 4 is positive 28. X times x squared is x to the third. Negative 4x times plus 2x, that's going to give me a negative 8. What is x times x? X to the second. Negative 4 times negative 10 is going to give me positive 40. I have an x here with no x here, so we tack on the x at the end. All right, okay, so that actually would be like distributing that through all of that. And then this next row, that's like distributing this through all of that. So here we go. Negative 5 times negative 7 is positive 35. X squared. There's not any x on these, so all of those are just going to tag along. Negative 5 times positive 2x is going to give me negative 10x. And a negative 5 times a negative 10 is going to give me a positive 50. All right, and once again, we want to put all of these together, but once again, we're looking for those like terms. There's only one x cubed term, no like term. There's only one constant term, no like term. But right here, excuse me, we have an x squared term. So we have two of those are like terms. And right here, we have x terms. So those are like terms. All right, so here we go. So I have 28 x to the third power. All right, I'm going to go ahead and just use these to add them together and not write it down separately like I did up here. So I have 40 positive x's and 10 negative x's. 40 plus negative 10 or 40 minus 10 is going to give me 30 x's. And then hanging out over here by himself is 50. So in this case, this binomial times this trinomial, when I was done, gave me a trinomial because this one was by itself, this one was by itself. No, I missed one. Oops. Excuse me. I knew that wasn't right. Sorry. 35x squared minus 8x squared. I missed that one completely. 35 plus negative 8 or 35 minus 8 is 27x squared. Some of you are probably screaming at the screen. All right, plus 30x plus 50. That's better. All right, the binomial times the trinomial gave me a 4-term polynomial, right? Because even though we started off with 6, we combine these two into one and we combine those two into one. And again, we can do anything from here. You can multiply any polynomial by any other polynomial. You simply make the rectangle, right? So if it was a trinomial times a trinomial, it'd be 3 times 3, which is 9. If it was a trinomial times a 5-term polynomial, you'd have 3 going down and 5 going across for a total of 15. All right, well, I hope that helps you understand multiplication of polynomials. Thanks for watching. We'll see you next time.